In continuation of the previous video, let's discuss activity 1 more. Here in activity 1, it asks you as the first serious activity you have regarding simulation. For the case of Sanatronics described before, simulate the number of units sold 1,000 times. Since it is the first session we are doing this type of activities, I'm gonna be more elaborative regarding them. On one hand, first it tells you Sanatronics described before. It is related to that activity, but in case you have no access to the previous session materials, here it was the case. Here it is the case that we discussed last session. Sanatronics believes that annual demand is described by the normal probability distribution. The mean or expected value of annual demand is 15,000 units. The standard deviation of 4,500 units describes the variability in the annual demand. So you have this case. There is a company, they want to model the demand, the annual demand they have, and they have noticed it follows normal distribution of mean 15,000 and standard deviation 4,500. This activity asks you to simulate the demand 1,000 times. And here in the hint it tells you you just need to generate 1,000 random normal numbers. Just let me correct this part. And let me correct it in this way. Hint, you just need to generate 1,000 random normal numbers of mean 15,000 and standard deviation of 4,500. Why? Because when you generate this type of random number, in fact, you are simulating the demand this company has. And when you do it 1,000 times, it is exactly the answer to this activity. When you do it 1,000 times, in fact, you have simulated this situation 1,000 times. And what is the main things you are simulating in this activity? The demand. 1,000 times, that could be 1,000 years. You simulate the demand according to this thing. Pause the video, and according to the formula you learned in the previous video, do the simulation on Excel. Now we are going to check the answer together. You should get something like this. You put the formula norm inverse random 15,000 4,500 in one Excel file, and you drag down everything for 1,000 rows, and in that situation you have it. Of course, since these things are random numbers, the numbers that you have generated are not the same as here, but when you check them, they should be around 15,000, and when you calculate the average and standard deviation, it should be very close to that. Since it is our first time we are doing this, now I'm gonna do this also for you in Excel so you can learn it better. Okay, let's do the simulation here with Excel in a more practical way. Okay, since we are gonna do it 1,000 times, so I'm gonna generate this as a half 1,000 times. Okay, now we have the number of simulation, and here, okay, equal norm dot in probability. Instead of probability, we put rand, and the mean was 15,000, and the standard deviation was 4,500. And now we get, as I told you, it always should be something around there. And now I'm gonna repeat it 1,000 times, and each of them is simulation. For example, when I ask you what is the result of the first simulation, you see, according to the first simulation, that is, for example, the first year, the demand is something around 12,748. About the second year, it is something around 21,058, and that's it. So let's go for all these 1,000 cases. And now we have it. One way that you can check if you are doing the right thing is to calculate the average and standard deviation of this data that you have created. When you want to check with average, okay, we are going to check the average with this formula. I'm going to select all of this thing. Okay, we have 1,000, and I close the formula, and now we can check the answer. See, before even I punch the button, if I have done it right, the number that we see over there, that is the average of all these 1,000 simulation of demand, must be something close to 15,000. Okay, and now I punched it, and you see it is 14,734. And when I run it more times, you see, even I get the average of 15,183. It should be something around that, because the random number that you generated is on this base. Now, if you are wondering that how I refresh this randomly generated normal numbers, I punch the button F9 on my keyboard. So let's do it another time. See? And for example, this one that now you see in front of you, 14,988. It's very close to 15,000. If we do the calculation, it's very close. On this hand, we have 11 something, just away from that thing. Okay, because we have a big standard deviation, if you make the standard deviation a smaller number, even when you calculate the average of this 1,000 simulation, the resulted number would be close to that. Similar things should happen to a standard deviation. Now, when you calculate the standard deviation, the results should be something around 4,500. And remember, to refresh your randomly generated numbers, you need to press F9. Now let's go and check the standard deviation of this sample that we have done together. And by the way, now implicitly you are learning how to create average and standard deviation for the simulations that you do in future. For example, you want to make decisions according to the simulation results, and one of the statistics that you need to do that is average as well as standard deviation. I should have told R, average and standard deviation. Okay, sorry for that. Now we go for a standard deviation. For the standard deviation, the formula that you use is of when you type ST, this helps comes to you. And let me just give you a point. For example, when I click on this standard deviation, and as you can see the abbreviation here, stdev.p, it says calculate a standard deviation based on the entire population. Okay, we don't have the entire population here, so it is not what we want. From now on, for this class and most of the simulation cases that you will have in future, you should use standard deviation for samples, because we are now doing a sample out of a population. The sample of size 1000. So as we can see here, it explains it clearly that it estimates standard deviation based on a sample. And so I'm gonna put this and selecting 1000 sample that we have here. Oh. And now I punch it. Let's check the result. You see, 4532, close to that thing. Let me now refresh my simulation. When I refresh my simulation, it gives me average of 14,963, very close average, and a standard deviation of 4,565. So now I can be sure that my simulation is fine. So these things that you see in front of you is the answer to activity 1. I have simulated the demand 1000 times, and the average is here and the standard deviation is here. They are proof to my correct generation, random number generation. And you may ask, what does it mean? It means that in the first year the demand is 16,400. In the second year the demand is 16,729. In the third year the demand is 13,116. Does it make sense? Absolutely it makes sense, because demand is a random number, so it has volatility, but the average of volatility is 15,000, and standard deviation of volatility is the average of random numbers is 15,000, and the standard deviation is 4,500. And here now you can see the result of demand for 1000 years, and that's the reason simulation is very popular, because it is easy, and you see how quickly you can simulate the demand for 1000 times. That equals to 1000 years. That's the reason when you get the results from simulation models, they are very reliable. And now we are back to our PowerPoint, and you should have a better understanding of what you see here. Here it is the formula. Here it is the in Excel norm inverse here, and here are the randomly generated numbers. Now we are ready for the next topic: how to generate uniform continuous random numbers between the lower bound, between A, the lower bound, and B, the upper bound. We have discussed all these things last session, and I have provided you with the local PowerPoints, vocal slides, and also YouTube video links. If you have any problem regarding uniform continuous random numbers, go and check them first before you do these things. Okay, when we want to create a uniform random number, again there is a formula, and here it is the formula. Rand as the engine of simulation over there, plus this formula that I'm gonna discuss it for you in the next video.